Alright, so here we need to write a function that takes a single argument, which is a number, and then we should calculate and return the sum of all the digits in the number. So let's declare a function. Now let's start by creating a variable and set it to 0. This variable will hold the running total of the digit sum. Now let's iterate over each digit of the number. The number could be, for example, so that could be the input of our function, and we have to return the sum of all these digits. So in order to do that, first we should iterate over this value. So that's what we are going to do now using a while loop. And now within the while loop, we should add the last digit of num to sum to this variable. And how we can get the last digit? By using the modules operator. And why we need to extract the last digit of the number? It is because we need to add its value to the running total sum of all digits, and by repeatedly extracting and summing the last digit, we can compute the sum of all the digits in the number. So this process guarantees that each digit of the number contributes to the final sum. And here we use the modules operator to extract the last digit, because it returns the remainder of the division of the num divided by 10. If, for example, we divide this number by 10, the remainder will be 7, which is equivalent to, say, sum equal to sum plus num. So this is a shorthand operator, and it's an efficient way to update the value of a variable incrementally. So now after adding the last digit to sum, we will remove the last digit from num. And let's see how we do this. And by this line we are removing the last digit of the num, because when you divide a number by 10, you shift all its digits one place to the right in the decimal system. So for example, if you divide by 10 this number, the result will be this one. And then by applying the math.floor, and keep in mind, with sum we are invoking the variable we initialize it to 0. And this operator is a shorthand assignment operator in JavaScript and in many other languages. So by applying the floor function, we remove the decimal part, leaving only this part because the floor function rounds down. So the flow is we extract the last digit of num, then we add it to the variable num, sum, sorry, and by this line we shift all remaining digits to the right, removing the last digits. This process is repeated in a loop, in a while loop, until all digits are processed and num becomes 0. Now let's return sum. And let's console log to see if we get the right result. And the final output is 35. If we sum all these numbers, the result is 35. If we sum 15, 3. So here we see the power of loops and basic arithmetic in problem solving by iteratively extracting and summing each digit. We can effectively process and manipulate the number. So in this exercise, basically we should write a function that takes a year as a parameter, and base it in that year we should then calculate the century it belongs to. So for that we will write here a function century. And for calculating the century, should write here math. So as you know, math is a native JavaScript method, and sale rounds a number up to the nearest. So to determine how many centuries have passed since this year, we should divide this year by 100. So let's console log the results. As you see, it gives us the correct century. For example, let's write another year. 18. It's great. So let's move on to the next exercise. In this exercise, we have to print the even numbers, and the limit will be the number we pass as a parameter to the function. First of all, we will set the starting point of the iteration to 1. This will ensure us that the loop begins with the first odd number and proceeds to print only the even numbers. Now let's write a while loop. This while loop will continue as long as I is less than or equal to n. Now let's write a condition that checks if the current value I is even. So this module operator is used to check if the current value I divided by 2 leaves a remainder of 0, which indicates that I is even. Now let's console log this. And last but not least, let's increment the value I by 1 in each iteration of the loop. This ensures that the loop progresses to the next number. So now let's try. So as you see, 2, 4, 6, 8, 10, 12, 14 are the even numbers up to 14. Great. Good, so here we need to write a function that takes a string as input and then constructs a new string made up of the first, middle, and last characters of the input string. So if, for example, we input this word, example, the output should be M, because we are making up a word with the first, middle, and last character. So that's what the exercise is about. So let's get to work. So we created a function named get first, middle, last, which take a string as input, and then we need to handle special cases of the input string's length before getting into the main logic of the function. The first special case is when the string is empty. Then the function should return an empty string. Then if the string has just only one character, and in that case the function should return that character. And if the string has 2 characters, then the function should return both characters. And by handling these cases, we guarantee that the function can manage short strings without trying to access elements that don't exist, which could lead to errors. Now we will try to capture the first character, last character, and middle character. So with this line we access the first character of the string. In JavaScript, strings are 0 index, meaning the first character is at index 0. Then, in order to get the last character, we first get the total number of characters, and then we subtract 1 character from this length, which gives us the index of the last character. The word example has 7 letters, 7 characters, and length of example -1 gives us this result. String 7 minus 1, 6, and the character that occupies this position then is the character that we will be subtracting. And then in order to get the middle character of the string, we pass as a parameter when we call the function. First we get the middle position of the string by dividing the length by 2. The math.floor method rounds down to the nearest number, which ensures you get the correct index for the middle character. Same word. For example, the word example has 7 characters, and if we divide example by 2, then the result is 3.5. This method, math.floor, converts this 3.5 to 3. So in this way we capture the central character of the string, which is determined by finding the halfway point of the string's length. To end this function together, these lines gather the 3 key characters we need to resolve this exercise. So return console log the result. So these first are these special cases, these single character strings and 2 character strings, and then the word we mentioned before, example, or for example dictionary. It builds a word based on the character we program in this function. So in this exercise, the task involves creating a multiplication table using the number provided as input. So the function will produce a multiplication table based on the number we enter as input. So now in order to iterate through the numbers from 1 to 10, we will set here a for loop Note that starting the loop at 1 allows us to include the initial multiplication and continue to generate the subsequent multiples by incrementing the loop variable. If, for example, we start the loop by 0, then we would miss the multiplication by 1, which is essential part of every multiplication table. So now, as we want to display the multiples from 1 to 10, we have to set this condition. So that the loop will run for 10 iterations. This ensures that all the multiples are included. So now we have to set the variable that store the result of multiplying the input number by the current iteration I. This line is very important for computing each multiplication operation within the loop iteration. So now let's console log our result. So in order to do that, we have to write a template literal here with those backticks, which will enable us to display a formatted string for each multiplication operation, so that we can show it in our console. So with those backticks, and now you write a $sign, execute the function. Let's write here multiplication table, and for example we will pass number 5 as a parameter. Let's see what we get here. So as you see here, we get our whole multiplication table from 1 to 10. So here we have to simply iterate through an array of numbers and check if each number, to see if it's odd by dividing it by 2 and checking if there is a remainder. So for that we can write a function. If it finds an odd number, it should return that number. If no odd number is found, we should return null. Keep in mind they are talking about just one number. So the first odd number it encounters, we should immediately return it. So let's first define the array we are going to work with. So here we defined a bunch of number, and then we will have to iterate through that array in order to test our function. So here our parameter will be array. So inside this function we will start defining a for loop. So once we are inside this loop, we should be able to identify and return the first odd number that we encounter during the iteration. So for that we will write an if statement that grab the current index, and through this module operator we calculate the remainder by dividing it by 2. And then we should check if the remainder obtained by this operation is not equal to 0. And this is important because if the remainder is not equal to 0, because when a number is divided by 2, if the remainder is not 0, it indicates that the number is odd. So as you know, if a number is even, it is divisible by 2 without leaving a remainder. So when an even number is divided by 2, the remainder is 0. And if a number is odd, it's not divisible by 2 without leaving a remainder. So when an odd number is divided by 2, the remainder is not 0. So if the condition is true here, It means that the index we are iterating is an odd number. And in this case, we should return this one, which is the odd number found in the array. Now here we should implement another return because they ask us to return null if no odd number is found. So here return null. So now let's try our function. So as you see, it returns our first odd numbers. For example, we right here first 10. They also return us 3. So as you see, they are asking us to return just the first odd number that we encounter, but in case we want to return all the odd numbers that are containing the array is containing, so we can simply declare here an array we could call odd and inside our if we remove this return and push inside here we return our array. Now here we get all the odd numbers that we encounter instead of the first one, just in case you see the other approach. So in this exercise we should write a function that takes two parameters, two numbers as a parameters, and print the numbers from the first to the second of the values you entered to the functions. That means these parameters represent the starting and the ending numbers respectively. So in simple terms, these functions should show us the numbers between these two parameters. So the first things we should do here is to assign the initial value to n1. So n1 is where the function should begin printing the numbers we are looking for. So for that, let's write let I equal to n1. So now let's write a while loop. And this while loop should iterate as long as the value I is less than or equal to n2. This will ensure us that the numbers are printed from n1 to n2. And now we will increment the value of I by 1. In each iteration of the loop, ensure that the loop progress to the next number. So let's console log our result. And as you see, we get 2, 3, 4 up until 9. So basically in this exercise we have to create a function that somehow reorganize all the elements of this array so that all the zeros in the array are moved to the end while maintaining the order of the rest of the elements. You see, it doesn't matter if they are not all numbers, we can work with them anyway. So let's start writing a function. There are many approaches that we can take in order to solve this exercise, but I will initialize to separate arrays. It will make it easier for us the manipulation and reorganization of the element later in the function, because here we will save all the elements that are not equal to 0 and here all the elements that are equal to 0. So we will split all the elements into these arrays and later we will concatenate them to ensure we reach our goal. So now we have to iterate our array. This time I will use a for each instead of normal or traditional for loop because it's cleaner and more readable. So now we are inside our loop. We have to separate the element into these two categories, non-zero and zero values. And we will do that with an if statement that will check if our core current element is equal to 0 and if it's equal to 0, if the condition is true, we will send our element to the array 0, and otherwise the element will be sent to the other array, non-zero values. And once we are done with this verification, it's time to concatenate both arrays. We'll first save it to a variable called constant called result, and here we'll concatenate non-zero to 0, because remember all these zeros, as the exercise said, should be moved to the end. So in this way we are moving all the zeros to the end. So let's return our result and let's console log our function. array, and here you see that all the zeros are moved to the end, so it's great. So here we will start by declaring, and here we will iterate over the second array. And once we are iterating over those elements, we'll push those elements into the first array, and then we return first array. Well, let's console log. And you see here we get our result. So keep in mind the exercise does not specify that we should write a function that gives us a different array with all the merged elements. So I choose the most simpler way that arrives to the result, and in this sense I used one of these arrays in order to merge the elements. So we need to write a function that searches for all instances of the substring apple within a given string, without considering the case, so uppercase or lowercase. We should ignore the case of the chapters. So the function should find all starting positions Alright, so first we declared a function that takes two parameters. The main string, that is the string in which we will search for the substring apple, and then the substring we are looking for within the main string. Then these lines convert both the main string and the substring to lowercase to ensure the search is case insensitive. Why case insensitive? Well, because we have to ensure that the function finds all occurrences of the substring regardless of the letter case. So we don't need to worry about matching the exact case. So we kind of eliminate the need for users to ensure their search term exactly matches the case of the characters in the main string. And then we initialize an empty array that will be used to store the starting indices of all occurrence of lower substring within lower main string. And now we have to focus on finding the first occurrence of the substring. So the method indexOf returns the index of the first occurrence of a specified value within a string. If the value is not found, then it returns -1. Remember, our main string represents the string in which we are searching for the substring. and this one lower substring represents this substring we are looking for. And here, through this method, we are searching for the first occurrence of lower substring within lower main string, and it returns the index of the first character of the first match, and the result will be assigned to this variable called index, which will hold the index of the first occurrence. Next, we will need to iterate through the main string and find all occurrences of the substring. So the loop continues as long as index is not -1. Remember, -1 happens when lower substring is not found in lower main string. The value of index represents the position of the current occurrence of the substring within the main string, and when index is -1, it means no more occurrence of the substring were found, and the loop stops. So then inside the loop, the current value of index, which is the starting position of the found substring, is added to occurrence array. This keeps a record of all the starting positions of where the substring is found. And then this line updates the index variable to the position of the next occurrence of the substring, because by incrementing the index by 1, the search moves past the current occurrence to find the next one. So let's print our result. And as you see, we get the output of the first occurrence of apple every time it appears. In this exercise, we have to create a function that reverses the string that we provide as input, which simply means to change the order of its characters so that the last character becomes the first, the second to last character becomes the second, and so on. And it will take a string as a parameter. Now we will initiate an empty string variable which will store the reverse string that we could call result. It will be empty. Now we will initiate a for loop that iterates through each character of the input string. And now we are inside this loop. We will make it so that as the loop progresses through each character of the input string, it adds that character to the beginning of the empty variable, and this action will effectively flip the order of the character, and for that result will be equal to the current index plus result. So in this way, as the loop goes on, it will add each character to the beginning. So return result. Oh, sorry, that should be outside. So now let's console log our result. And the string is successfully reversed. Here, if you want, instead of a traditional for loop, you could implement a for off loop, which would be something like this: item of and the result is the same. But in my opinion, it's more readable, the for off loop, than the traditional one. So both are great to implement in this case. Now in this exercise we have to create a function that checks if an array is sorted in non-decreasing order, meaning that each element is either greater than or equal to the previous one. Which will take an array as a parameter. So inside our function we will declare a for loop. But here is something we have to pay attention to, because as we need to compare each element with the next one in order to determine if an array is sorted or not, we have to make sure that the loop iterates through all elements of the array except for the last one. So in order to do that, we have to write here -1. So attempting to access an element beyond the bounds of the array will lead to an out of bounds error, which can cause our program to crash. So once that is clear, let's continue to identify if the array is sorted by comparing each element. So for that, let's write an if statement. So this expression is used to access the next element in the array during the comparison process. So if the current element is greater than the next element, it indicates that the array is not sorted, and the function should return false. Otherwise, we return true. So let's check our function. False. The first one is false. Great. Let's try the second one. It's true. It's ordered. So now we should write a function that takes an array as input and returns another array containing the two highest number from the input array. So let's write here function, and directly in the return we will sort the array in descending order. Sort is a method in JavaScript that sorts element of an array and returns the sorted array. But in this case, to sort elements in descending order, you need to provide a custom comparison. So in this case, if the result is negative, it means that A is smaller than b, so b comes before a, resulting the array in a descending order. So once the array is ordered in that way, we will use another JavaScript method called slice, and as parameter 0, 2. With this method, we're extracting a portion of an array starting from 0 inclusive up to the index we want, in this case the second one. Therefore, slice selects elements at index 0 and 1, because this second parameter is not included, so 2 is not included. The first parameter is included and the second is not included. That's very important to know. So let's console log. So as you see, the two highest number are 4 and 7. But what would happen if there is a duplicated number? If there is a duplicated number, for example 7, and 8, we are not getting any more the two highest number. So for this purpose, this function is not giving us the expected result. So for that we should make a small change, that is to use a JavaScript expression that is used to remove duplicated elements from an array, to replace this array with now we have again the two highest elements of the array. This new set creates a new set of objects from elements of the array. A set is a collection of unique values, so meaning it automatically removes duplicates. These 3 points are spread operator that is used to spread the element of the set into a new array. Alright, so we should write a function that checks if a given number is a palindrome. Remember, a palindrome is a number that reads the same forwards and backwards. So for example, for this number, the function should return true, because this number reads the same forwards and backwards. And for this case, it should return false, because that does not read the same forwards and backwards. So let's start with our function. Alright, so first we need to convert the number we pass as input to a string, so that we can directly access and compare individual digits using their indices. Otherwise, as a number to compare digits, we would need to extract each digit through repeated division and modules operations, which is much more complex. And as string, we can directly compare characters at position 0 and 4, 1 and 3. And for that we use this method toString. And then we initialize two variables that we will use to compare characters from both ends of the string moving towards the center. For example, left is set to 0, and this variable acts as a pointer that starts at the beginning of the string, and it will be used to go through the string from the leftmost character. So it is the first character. And the variable right, we set it to -1 string.length -1, and this variable acts as a pointer that starts at the end of the string, and it will go through the string from the rightmost character, the last character. So left and right are like pointers initialized to the first and last character position of the string. Now, after defining this variable, we will have to create a loop that could be a while loop that loops until the pointers meet in the middle. So this loop will continue as long as left is less than right. This condition ensures that the loop stops when the left and right pointers either meet or cross each other in the middle of the string. And this is important because once the pointers meet or cross, all relevant characters comparison have been made. And then inside the loop, the characters at the current position of the left and right pointers are compared. Here, string left, we access the character at the left pointer position, and here at the right position. If these characters are not equal, which we evaluate it through this operator, it means the string is not a palindrome. So if the characters at left and right are not the same, the function immediately returns false, and the return statement exits the function, indicating the string is not a palindrome. And if the characters at the left and right are equal, then the pointers are moved closer to the center. And for that we will increment the left pointer, moving it one position to the right, and decrement the right pointer, moving it one position to the left. For example, in this case, it evaluates if they are equal and one from the left and right position are equal, then it moves the pointers towards the center. Here it will evaluate it again, and it concludes that they are also equals, and it will again move the pointers towards the center, as we here established. So as you see, it's all about efficiently checking every character, if every character are the same, comparing the left with the right pointers. Now let's print our result. And here it gives us undefined because I forgot to complete the function. True. This return true completes the palindrome check by indicating that the string has passed all tests after all necessary comparisons. So this function flow ensures that the function only declares the string as a palindrome when every character pair from the start and end of the string matches. Therefore, the loop only exits when all characters from both ends match. If any mismatch occurs, then the function returns false immediately within the loop, as we here indicate. Alright, in this exercise we need to write a JavaScript function that prints a star pattern, as this one, where the number of stars increases from 1 to 5. This is the maximum. And then decreases back to 1. So in order to do this, let's start by creating a function. So as you see, this exercise does not require any parameters to be passed to the function. The function should generate and print the pattern regardless of any input. And first we declared a variable that sets the value of n to 5, and this value will be used to control the number of lines and maximum number of stars in the pattern. It's declared in a constant, meaning its value cannot be changed once it has been assigned. It's kind of represent the h of the top half. Now we will generate and print the top half of the star pattern, where the number of stars increases from 1 to n. So we initialize the loop counter to 1. And this is so because in order to generate a star pattern that starts with 1 star and increases by 1 star each line until it reaches n stars 5, we have to set it to 1, so that the first iteration of the loop will print a line with 1 star. And then this condition it means that the loop will continue running as long as I is less than or equal to n, which is 5. And then we increment the loop counter by 1 after each iteration. And then we console log this line, which repeat method is responsible of creating a new string by repeating this string I times. I represent the times it should be repeated. This should be repeated according to the loop. And trim is a method that removes any leading or trailing white space from the string. This is useful because the method, the repeat method, generates a string with a trailing space. And now we will write the loop that will be responsible for creating and printing the bottom half of the star pattern, where the number of stars decreases to 1. So we initialize the loop counter to n minus 1, meaning that if n is 5, then I will start at 4. Then the loop will continue running as long as I is greater than or equal to 1. I forgot to 1 here. So why 1? The goal here is to print lines of stars that decrease in number from n minus 1 down to 1. So starting from here, n minus 1, we ensure that the loop starts with the line that has the maximum number of stars. So here. Just below the peak of the pattern. And this condition means that the loop will continue to execute as long as I is greater than or equal to 1. This ensures that the loop runs until I reaches 1, printing all the necessary lines of stars in the bottom half of the pattern. So let's print the pattern just by calling the function. Its name is createPattern. Repeat is not defined. Oh, I wrote here a comma instead of point. It's a point because I am applying a method to that string. And the result is as expected. Alright, so in this exercise we should create a function that takes an array as input and determines if every element in the array is identical. And if the array is empty, we will return true, as we will treat an empty array as having all identical elements. So if all elements in the array are the same, the function should return true, and if there is any element that differs, the function should return false. So as we said in the first part of the function, we are considering an empty array as having all items the same. So we start by checking if the array is empty, and if it is, the function returns true, assuming that an empty array can be considered as having all identical elements. Next, we will store the first element of the array. and this will be used as a reference to compare with the rest of the items in the array. Then we will iterate over each element in the array, and for that we will write a for loop. So here we define a for of loop that is used to iterate over iterable objects such as array, strings, maps, and it allows you to loop through the values of an iterable object. It's much more simpler and readable than the traditional for loop, as you don't need to manage loop counters or worry about array length and so on. It automatically iterates over the values of an iterable object. So inside the for loop we nested an if statement that checks if the current item is not equal to the first item. So each element will be compared to the first item, and if any item is found to be different from first item, the function immediately returns false. And if the loop completes without finding any item that is different from first item, then the function will return true, indicating that all items in the array are the same. So now let's see the output in the console. So in the first case, as all elements in array 1 are the same, we will get true since all elements are identical. And in the second case, they are all the same except the number 2, which is different from the rest, so we get false. Good, so here we should write a function to check if the first and the last items in an array are the same. So first we verify the array is not empty, and then we check if the first and last elements are equal. Right, so first we access the first element of the array. Remember, in JavaScript, array indexing starts at 0. So array 0 is the first element, and then we access the last element of the array. First, array.length gives the total number of elements in the array, and then subtracting 1 from the length gives the index of the last element, because array indexing starts at 0. For example, if the array has 5 elements, r.length is 5, and the last element index is 4, and we get to that 4 by the -1. 5 minus 1. So this way we access to the last element of the array. And this strict equality operator checks if the values on both sides are exactly the same. So let's print our result. So in the first example, it returns true because the first and last element are both 1. And in the second example are 1 and 5. It returns logically false. So here we have to find the longest word of the string that we enter as input. So first of all, we will need to split the string into words using a JavaScript method called split. This argument specifies the separator at which to split the string. In this case, it's a single space, so the string will be split wherever there is a space, and this will allow us to work with individual words in the input string, so that we can process the input string at the word level, making it easier to find and manipulate the longest word in the string. Now we have to iterate over the words array to find the word with the longest length. And for that we will implement the reduce method. That will take two parameters, the accumulator and the current element. The reduce method is always takes a callback function that two parameters, and right at the end we will set the accumulator to an empty string. So in a way, the reduce method can be seen as another way to implement the for loop. Both approaches achieve the same result, but the reduce method offers a more clear approach for performing operations on arrays, particularly when dealing with tasks that involve accumulating or transforming data. But that's a matter of personal preferences. So now we have to update the accumulator based on whether the current word is longer than the previous longest word, ensuring that the accumulator always holds the longest word found in the array of words, this one. So return so l.length got the length of the current word, accumulator.length holds the longest word found so far, and here we use the ternary operator that is like a conditional in order to evaluate the condition. So if the condition is true, meaning that the length of the current word is greater than the length of the accumulator, it returns current L. This indicates that the current word is longer than the previous one. And if the condition is false, meaning that the length of the current word is not greater than the accumulator, it returns accumulator, which indicates that the previous longest word remains the longest. So now let's console log. First, let's put this in a constant. And it's returning just the letter and not the word. Let's see why. Oh, my mistake here. I did not include a space between the quotes in the split method. Hurry. So here we have the right result. Remember, if I don't include a space here, I will get individual words. Otherwise, I just get individual letters. That's important to know. So in this exercise, I'm not interested to get individual characters. So the right way will be like this. In case you want to implement a traditional way here for doing this exercise, you could define here longest word as an empty variable. Note that longest word here would play the role as accumulator, but it's defined outside. It's a different way to do it, but maybe you will understand better how reduce method work. Now inside the for loop, let's define the current index. So here, if the length of the current word is greater than the length of the longest word, it means that the current word is longer than the previously found. So in that case, longest word variable will be updated. How we do that? By assigning this variable current word to the longest word. Here, instead of result, we will return longest word. Same result. Great. So in order to solve this exercise, we will create two functions. The first function will be responsible for determining whether a single number is prime or not. It will encapsulate the logic for prime number checking. And this function get non-primes, on the other hand, will be responsible for iterating through an array of numbers using this function isprime to filter out the non-prime numbers. So in order to focus on our function isprime, let's start with, we'll take a number as a parameter. Let's start with an important verification that returns us false if there is a number that is less than 2. Because remember, prime numbers are defined as natural numbers greater than 1 and that have not positive divisor other than 1 and themselves. So if a number that is less than 2, it cannot be prime bar. So if someone enters a number less than 2, such as 0 or negative numbers, this condition ensures that it will stop there. So now let's create a loop that starts with 2 and continues until it's less than or equal to the square root of the number. So it will iterate over all numbers from 2 up to the square root of the number. Our loop variable represents the potential divisors of the number. So once we're inside this loop, we will need an if statement that checks if number is divisible evenly by our loop variable that, as we said, represent the potential divisors of the number, and if so, it immediately determines that the number is not prime and return false. So this expression calculates the remainder when number is divided by I. If the remainder is 0, it means that I evenly divides number. So it is a factor of number. And this I is found to be a factor of number. It means that number is not a prime number because prime numbers have exactly two different positive divisors, 1 and the number itself. And if no such factor is found within the loop, the function continues to execute. And if it doesn't find any factors other than 1 and number, it will return true. Once we are done with the function that determines whether a single number is prime or not, let's continue with the other function that will iterate through an array of numbers, and it will implement this function that we already created. So this function will take an array as input, and then we will initialize an empty array that will store the non-prime numbers that we find. Now let's define a for loop that iterates over that array. So now let's assign our current loop variable to a constant. And now we will check if the current number is not prime by using our function isprime. So for that, here we will write an if statement. And it will evaluate if our function is. So if our function returns false, it means that the current number is not prime. So it will get pushed into the new array that we create here. Let's create an array here. So this function takes an array of numbers, that could be this one, and iterates through each number, check if it's not prime using our function isprime, and collects all non-prime numbers into this array, which is returned here. Let's console log if it's worked. So it's working perfectly. Alright, so the tricky part in using the for each method in this context is that for each is a method designed to iterate over elements of an array. In here we will be dealing with a single number. So that is what we have to take into account before beginning with this exercise. So this function should correctly count and return the number of digits in a given number. For example, in this number we have 1, 2, 3, 4, 5 digits. So that should be the output. But we have to use a for each, and we are dealing with a single number, not an array. So we need to convert this input, this number, into a string and then split it into individual characters to make it, or to convert it into an array. So first, to convert the numeric value into a string, we will apply the toString method. This method allows us to treat the number as a sequence of characters. Then we apply the split method. So in this exercise, and now that we have an array of characters, we can apply the for each method to iterate over each element in the array. And this is an arrow function passed as an argument to for each. It increments the counter variable for each element in the array, and counter plus plus is executed for each element in the array, counting each digit. And finally, the return counter returns the total count of digits. So let's console log to see what we are getting. And as you see, 9, it counts the number of digits that we enter as a parameter for this function. Our task is to implement a function that takes an array of objects as input and return a new array with objects containing only specific property. In this case, we have a long object here containing many properties, and we just have to return or select 2 of those properties. So we have to extract the property label and slug. So let's start by defining the array we're going to work with. Let's write better a constant. Now let's write our function. We could call map array. Take an array as input. And here we will return. We'll define our whole function in the return. And here we will iterate over the array using our map method, which will receive each object from the array as an argument. Inside our function, object destructuring is used to extract label and slug. So we are returning a new object containing only label and slug. The extracted label and slug property are used to create a new object. For this kind of exercise, map is really great because it's used to transform elements of an array. So now we will console log our function to see what we are getting. So what we have in this exercise is an array of objects. Each object contains its own set of property and values. But in some cases, like here, the value is empty. So what we need to achieve through a function is that each object where it has an empty value as here, it appears as null as here. So let's get to work. How we could name this function, we could say missing value. It will take an array as a parameter. Now we need to iterate over each element in the array. And for that we will write the map method. And now in the next line we need to write a code that checks if the current object item does not have a property called value. So for that we will write an if statement. And here we have to turn to a JavaScript method that help us to check if a specific property, in this case value, does not have a property called value. So we will write here has oops, 。 . property, and if this is the case, the item value is set to null. Turn. So now let's console log our result. Cannot read property of undefined. Maybe this is disturbing us. So, as you see here, it's returning our expected result. Great. Good, so here we should develop a function that takes an array of names and constructs personalized greetings for each name, resulting in a new array of these greetings. So in order to do this, we will create a function that takes an array as parameter. First, we initialize it an empty array to store greetings, and then we will iterate through each name in the input array that comes here. And inside the loop for each name, we will construct a greeting message using template literals. This syntax allows embedding expressions inside strings. And then after creating each greeting message, it will be added to the greetings empty array that we defined there using the push method. This will modify the greetings array by appending each new greeting. So finally, after all names have been processed and greetings created and stored in the greetings array, the function returns greetings. This array now contains all the personalized greetings, which we will see now through a console log. And as you see, the function effectively takes an array of names, constructs a personalized greetings message for each name. Great, so this function should take a sentence as input and remove the last vowel from each word. So let's start declaring a function and then define the vowels as a set for quick lookup. So here we created a set name vowels containing both lowercase and uppercase vowels. And this guarantees that the function can identify and handle vowels regardless of their case in the input sentence. And then we will split the sentence input into an array of words based on spaces so that we can easily manipulate it. So a split method in JavaScript is used to divide a string into an array of substrings, which allows for easy manipulation and processing of individual words. And now we will have to set up the functionality to find the last vowel in each word of the words array. So here we are iterating over each element of an array of this array words. And here word represents each element of the words array. And the function begins by initializing this variable to -1. And this variable will store the index of the last vowel found in the current word, in the current element being iterated. And initially it is set to -1 to indicate that no vowels have found yet. And then we will iterate backwards through the word. The for loop starts from the last character of the word, and it starts from the last characters and it iterates backwards. And inside the loop we should check if the character at index I is a vowel. So we define the logic for identifying or removing the last vowel from each word in the sentence. In the condition check, we invoke the set that we defined right at the beginning, which contains all vowels, both uppercase and lowercase. Word I access the character at index I of the word, so the current element. And with the method has, we check if this character is a vowel. The has method of a set returns true if the set contains a specific value. So if the character at word I is a vowel, the condition evaluates to true. And if the condition is true, the index I is assigned to last vowel, which means that this variable last vowel index will now hold the position of this vowel. And why we iterate backwards? Because we should find the vowel, because we should find the last vowel in the word. And now we should remove the last vowel from a word if a vowel has been found. And this step is important to achieve the function's objective of removing the last vowel from each word in the sentence. So with the if statement, we check if a last vowel was found in either word. And if a last vowel is found, then the code removes this vowel by creating a new string that excludes the character at last vowel index. thanks to this slice method, which is used to extract parts of a string without modifying the original string. Here we extract the part of the word from the start up to the last vowel, but not including the last vowel. And then we extract the part of the word from the chapter immediately after the last vowel to the end. And then by concatenating these two slices, the chapter at last vowel index, the last vowel is removed from the word. And now let's join the modified words back into a sentence, and then we console log to see our result. And as you see, the last vowel of each word is successfully removed. Here we simply have to create a function that removes all falsy values like undefined, null, not a number, and just leaving the numbers. So regardless of the data type, there are values that are falsy, like undefined, false, not a number, 0, null. So the task here is to implement a function that filters out those values from the input array and produces the expected output. So let's get to work. So we'll take an array as input. Now we will define an empty array. Now a for loop. We'll write a for off loop. And now inside our for loop, we will write an if statement, which will be the key of our exercise, because just by implementing this if statement, we will be filtering out those falsy values from the input array. And why is that? Simply because when you have an if statement, it evaluates the truthiness of the loop variable. So it's doing the work of filtering out the array for us, just without writing anything else as just an if statement. We don't have to care about writing any additional code. If the if statement evaluates that our loop variable is falsy, it will just skip over and it will not read it and will not push it to our cleanit array. And if our if evaluates that our loop variable represents a truthy value, the code block inside this if will be executed and the element will be included in our cleaned array, which will be tested right now. So let's see in our console log. So as you see, we're getting just the right values. Alright, so here we have a nested array. So you know, an array can contain elements of various data types, including other arrays. So like in this case, when an array contains other arrays as elements, it's referred to a nested array or multi-dimensional arrays. So what they are asking us in this exercise is simply to convert a multi-dimensional array into one-dimensional array. So in a way, we have to remove all these elements and place them in a single level like we have here. So the function that we're going to create now should return a single level array containing all the elements. So we can create a function called now we will have to iterate through each element of the input array. For that we will write a for loop. Next, we should write an if statement that checks if the current element of our loop is an array. And in order to know that, we should apply a native JavaScript function called array.isArray. So array.isArray is just a JavaScript method provided by the language itself, which is part of the array global object, which means it's available globally and can be used anywhere in your JavaScript code without needing to import any external library. So in the next line we will apply a famous programming technique called recursion. Recursion is simply when a function calls itself to solve a smaller instance of the same problem. So in this case, convert array will be called in order to flatten the nested array. So here we will. So our function convert array is designed to flatten arrays, but it also needs to handle cases where elements of the input array are themselves arrays or nested array. So to achieve this, the function employs recursion, meaning that, as we said before, that it calls itself within its own definition. So this recursive call ensures that all levels of arrays, or how to say, all levels of nesting are properly flattened. And the variable nested array stores the result of the recursive call, which represents the flattened version of the nested array. So now it's time to add all elements of our constant nested array to new arrays. So for that, here, array spread operator And we use the spread operator because the push method expects individual elements as its arguments, not arrays. If here you pass an array, it will be added as single element. And that's not what we want when flattening arrays. So with our spread syntax, we effectively flatten the array. Each element of the nested array becomes an individual argument to the push method, so they are added as separate element to new array. So now inside our if statement, we should define what will happen in case the current element is not an array. So to solve that, we will add here an else block, so this block will be executed if or when the current element is not an array. This means it's a single element, not a nested array. But anyway, it needs to be included in the flattened result. That's why we add it to the new array. So after writing this block responsible for adding non-array elements, so it's time to return new array. Great. So according to the instruction of this exercise, we should write a function that takes a sentence as input and reverses the letters of each word that has 5 or more letters, leaving the rest of the words unchanged. So we have to reverse words based on their length, keeping shorter words unchanged. So in order to start, string as input. So first we will turn our string into an array of words. And for that we will use the JavaScript method split. So splitting the string into an array will allow us to manipulate each word individually. And it's also very important to reverse the string. Once we have the array in our words constant, we will iterate over each word of the array, and for that we can use a for loop, but in this case I prefer to use the map. It's the same, but it could make the function more readable. So once we inside our loop, we will check through an if statement if our loop variable item has more other than equal than 5 character. and if that's the case, it will reverse the characters of that word. In this case, we will use the split and reverse method, JavaScript method. So before applying the reverse method, we will have to convert our word into an array of individual characters. This step is very important to reverse it because it operates on arrays and not directly on strings. And last here, let me apply another method called join, which will help us concatenate all the elements of the reversed array back into a single string. Let's save all this code block in a constant. Let's return treated words. Let's console log. So as you see, the longest word here is George, and it is reversing it. But as you see, it looks like they are all separated, like they were elements in an array, and we just want to convert it into a single string. So let's use again here the join method. And there it looks like a string. So each word that meets the condition of having 5 or more characters has its characters reversed as George, while the other words remain unchanged. What we are asked to do in this exercise is to create a function that takes a string as input and returns a new string with the first letter of each word capitalized. String as input. Now we will split our input string into an array. Now let's define the array that will store our result. Now we will iterate over each word. So inside our for loop, we'll have to focus on the line of code that capitalizes the first letter of the word while leaving the rest of the word unchanged. And for that we will have to use two methods, one that returns as the word that extracts the first chapter of the word, and the other one that converts that chapter to an uppercase. So let me show you how it looks like. So the char_add method returns as the chapter at the index 0, which is the first one, and to uppercase will convert our chapter to an uppercase. So the next step is to concatenate the rest of the word with this first chapter that we converted to uppercase. For that, right here, plus item, and here we will write the method slice that with returns a substring of our word starting from index 1. Just by writing as parameter 1, well, we are telling the method to return as the word from the second chapter up to the end. Just so we are leaving out the first one, which is the 0, which was taken by this part of the code. We are interested just from the second to the end. Let's save all this into a variable. So each capitalized word is added to our empty array here, which is the array that we are going to return now. So as you see, we are getting the expected result here. Let's write again dot join in order to get string. So it's great. In this exercise, we have to move a particular number that could be in any position, for example 5, 7, 9. That could be in any position to the first position of the array. This involves locating the number within the array, extracting it from its current position, and then inserting it at the beginning. So the function should ensure that if the number exists in the array, it is moved to the front while maintaining the order of the other elements. And it will take two parameters, which will be the array and the number that we want to move to the front. Let's start now by searching for the index of the number. This array method indexOf returns the index of the first occurrence of num in the array, or -1 if the number is not found. This is a very important step because by finding the index we know the position of a particular number within the array. Without knowing the position, we can't perform any operation regarding to this exercise. Now let's make a simple verification. For the case the number would be not found. And remember that if returns -1, it means the number was not found, so index should be different to -1. And if that's the case, it means that the number, if the flow here continues, it means that the number was found. Next, we should remove that element that we found here in index. We should remove it from the current position, and for that we will use the splice method. Which will take two parameters. The first parameter will be index, and the second one index because it's the position of the number we want to move, and 1 because it ensures that only the element at the index position is removed. So in this way we are preventing any other elements from being removed unintentionally. So if, for example, we want to remove number 3, the index of should be returning the number 2 because it's 0. Every array starts from 0 position, 0, 1, and 2. And 1, we are in the second parameter, we are telling splice that removed just one element. And now, considering that we have to move the element to the first position, we can apply the unshift method to add the element at the start of the array. Remember, unshift adds one or more elements to the beginning of an array and returns the new length of the array. And why this argument moved element at the position 0? Because we are accessing the first element of the new array that splice is returning us. The new array that contains the removed element. So I guess we are done so far. Let's see if it's worked as expected. So the first parameter should be the array we want to operate with, and the second one the number we want to move to first, and in this case could be any number of the array. For example 5, let's try with 5, and you see 5 is moved to the front while maintaining the order of the rest of the array. Same with all the numbers we want to try. So here in this exercise we should write a function that groups an array of employee objects by a specified property. So for example, the ones who work at Facebook should be grouped together under the Facebook key, and the resulting object will have keys for each company, and each key will map to an array of objects from that company. So in order to see that in the code, let's start and the property. And in this function we will use the reduce method. Remember, reduce method iterates over an array, applying a function to an accumulator and each element in the array to reduce it to a single value. It just takes an initial value for the accumulator and updates it with each iteration. Accumulator is like an empty array we define when we use the traditional for loop. The empty array we find outside the for loop. So let's start by checking if the accumulator has already any property. So here we check if the accumulator object already has a property corresponding to the value of L property. If it doesn't exist, we initialize it as an empty array. This guarantees that we have an array ready to push the current element into for our grouping purpose. Remember, or take into account that the property L specified by property could be any property of the object array. For example, if properties is set to company, it will access the company property of each object L in the array. Similarly, if property is set to ID, it will access the ID property of each object. So with this syntaxis, we are accessing dynamically the property of L, the element specified by property. So with that being said, let's now access the array stored at the key represented by L property, but now in the accumulator. So you will see how practically in one line we resolve the exercise thanks to this reduce method, which might be a little bit complicated, but it makes it possible to write a little bit less code. Push. And here we push the current element into that array. Now let's return the accumulator. Oh, sorry, here I forgot to write the second argument of the reduce method. Which represents the initial value of the accumulator. It initializes the accumulator as, in this case, as an empty object at the start of the reduction process. And this empty object will then be populated with arrays of for each unique property value. So this console log should log the result returned by our function groupby, which is the grouped object based on on a property that in this case, for example, we could write company, and as you see here we get the result is grouped by based on the company property. So the output shows the employee grouped by their respective company. Same if I write here ID or yes, ID. So remember, in this line we access the array stored at the key represented by the element, the current element, in the accumulator. Then we push the current element into that array, and this is what effectively groups elements with similar property values together within the accumulator object. So here we have an array of employee objects, and we should filter this array based on the years property. Here, this one, and we should return only those who have worked after 1990. And this involves creating a function that iterates over the array and checks each employee's work years and returns an array with the names. So now let's initialize two arrays, two empty arrays. So a new array will be for storing the names of employees, and compared array for temporarily holding the years of employment. New array will eventually contain the names of employee who worked after 1990, while compared array will make as easier the comparison process. So this separation helps organize the logic and data manipulation. Oh, here I forgot to write our input array, and now we will write a for loop that will read that array. And now inside this loop we should extract the starting year from the years property here. And why we should extract the starting year? Because we have to compare it with the year 1990 and determine if an employee has worked after that year, as our exercise has asked to do. And after extracting it, we will send it to compared array. So compared array, push, and the way to extract it is by accessing to that specific property of the current element, years. And how we extract the exact portion of this date? Just by applying the method substring Oh, I forgot a parenthesis here. My mistake. because we are operating inside the push method. So here by applying substring, so now after filling this array, we will have to write another for loop that iterates through each element of this array that we just worked with. And to save time, we can copy this and just change some. And this, as we are working with another loop, we have to change the variable that we use as the loop counter to iterate over the elements. Otherwise, if I don't do that, it will conflict with the first loop. And once we are inside this loop, we will check if the starting year of employment for the current employee is after 1990 . So if the current element we are iterating over compared array is after 1990, if it's true, we add the element to the new array . But just the name, remember. So for that we should access to that the name property, because we should collect only the names. Here I put compared array in the wrong place, sorry. And we will return new array. Because new array is the array that contains the names of the employee who worked after 1990. So now let's and as you see, we are getting employee number 1, which is the only one who worked after 1990. There is a shorter way to do it, so I will show you quickly, which is by using a combination of map filter and map method. Through this filter method, we're accessing the years property. Years slice, which is another way to extract the date. Both works perfectly. Once we got the dates, we will iterate over the names with the map method. We save it in a variable response. A shorter way to achieve the same result. So the function that we should create in this exercise takes an array of country objects and evaluates each country's area. And then it adds a new property, size, to each object if the country's area is greater than 1 million. In that case, the size property will be set to large, otherwise it will set to small. So the function processes all objects in the array, ensuring that each one has the size property based on the particular criteria. And finally, it should return the modified array of the country objects. Now let's declare a for loop that will iterate over the array. And here we should access to the property area in order to evaluate properly the size of each country. So declare an if statement. Area. So in case the size is greater than 1 million, then we will add the property just by writing countries. Large and else country size small. So note that here we are adding a new property called size that does not exist. And the value of this property is set to large, indicating that the country is greater than 1 million. And by this process we are modifying the object by including a new property. And once added, this property becomes part of the object's data structure by providing the new information. So return. So the new property large, small. We could also do this exercise with the map method. I'll show you quickly. Create operator. So with this line we are creating a spread operator. A spread syntax to create a copy of the current country object item. We're creating a copy of item, and then we add a new property called size to that copy with a new value that we want to add, and finally it returns the modified object. Same process as the previous one. Else. And here small. Same results here. So here we have an array of objects representing people, and we should create a function that iterates through each person in the array and counts how many times each person appears. Sorry, not each person, each name appears. Say each name appears. So we should create a function that returns a new array of objects where each object contains a name and the count of times that name appears. So basically the new array should provide a summary of how many times each name appears in the original array of people, which is this one. This one is the original array. So people is the input array. So first we will initialize an empty object. Which will be used to store the count of times of occurrence for each name. It will be like a container to track the times we encounter the names during the iteration. Note that we don't define here an array. It's better an object because it allows us to access counts by name, like looking up words in a dictionary, which is faster than searching through an array. It's like having labeled compartments for each name, making it easier and quicker to keep track of counts. Now let's iterate over the array. Here we will use a for each. Here we are accessing the count associated with a specific name within the name counts, these objects that we defined here, and this will be equal to same here we use a shorthand conditional. By this expression, we are checking if there is already a count stored for the current person's name in the name counts. And if a count exists, it increments the count by 1. Otherwise, it initializes the count to 1, as we define here. By this conditional, we're basically updating the count that we defined as empty object. So now we have to iterate over each name in the name counts. It means we should retrieve all the unique names stored as keys in the name counts object, and for that return we use object keys name counts, and this object .keys allows access to each unique name stored as a property key within the object. We're mapping over these keys, creating a new array of objects where each object contains the number and the count of occurrences associated with that name. But for that we still should map over I sorry, not name, item, which is the current element of our map. So what we are doing with this map method here is to iterate over each key in the name counts object and as we iterate over, we construct a new object with two properties: name, which stores the current name being iterated over, and count, which retrieves the count of occurrence associated with the name from the name counts object. And this function is creating and returning these new objects. So now we We'll see how it works. And it works as expected. We are returning each name and how many times it is repeated. In the function we have to create to resolve this exercise, we have to iterate through an array of people and collect the full names of those persons earning over 100,000. So for each person we will check their salary, and if we exceed 100,000 we will combine their first and last name into a single string and add it to the accumulator, because we're going to use the reduce method in this function. So we are applying the reduce method, and we start with an empty array as the accumulator, and for each element in the people array it will apply a function to modify the accumulator. That's how reduce method works. So the function will process each element and update the accumulator, and finally returning the accumulated result after all elements have been processed. So after defining the reduce method, we will check if the current person's salary is greater than 100,000. So if the salary is greater than 100,000, it constructs the person's full name by concatenating their first and last name. This full name is stored in a variable, and this variable will be added to the accumulator. And then we will return the accumulator. and we are getting the names of the person who exceeded that amount. So our exercise is correct. So here we should create a function that increases each employee's salary by 10% and then return a new array with the updated salaries. So let's first write a function that calculates. So the number represents the number to calculate the percentage, and we will multiply it. We multiply the number by the fraction of the percentage over 100. In this way we are calculating the percentage of the number. And now we will create another function. So with the map method we are iterating over each object, and the map method is appropriate for this exercise because it simplifies operation within an iteration by array. Oh, my mistake, I forgot the percentage. We are going to apply, which percentage it says 10%. So as the second parameter, 10%. So here we have the rise applied to each salary. Good, so here you are given two arrays of objects, and the task is to create a function that combines these arrays in a way that mimics an inner join operation in SQL. An inner join in SQL is a type of join that returns only the rows from multiple tables where there is a match based on a specific condition. It combines records from two or more tables based on a related column between them. If no match is found, the row is not included in the result set. So we will start creating a function that will take three parameters: the first array, the second array, and the key on which the join is based. Then we will initialize a result array to store the resulting object from the join. Then we will create a loop that iterates over each element in the first array. And within this loop, we will create another loop that iterates over each element in the second array. So now inside this inner loop, we should check if the value of the key property in the current object from the array 1 is equal to the value of the key property in the current object from the array 2. Remember, an inner loop in programming refers to a loop that is nested within another loop known as outer loop. This nesting is used to handle more complex operation that requires multiple levels of iteration. So to do this check, we will use an if statement. So for each combination of elements from array 1 and array 2, the condition checks if the value of the property specified by key in the current element of the array 1, is equal to the value of the property specified by key in the current element of the array 2. So if the values are equal, it means there's a match based on the specified key. So if the condition is true, which means the key values match, a new object is created by combining the properties of the current object from array 1 and array 2. And this combined object is then added to the result array. And after both loops complete, the function returns the result array, which now contains all the combined objects where the key values match. So here we will return result. So now let's console log. So this shows how the inner join function combines objects from students and scores based on the matching student ID values. It is just reflecting the fields where the ID are the same. Alright, so in this exercise we should implement a function to perform a left join similar to SQL. So for the ones who don't know what a left join is, it's a type of join that returns all records from the left dataset, which could be in this case this one, the first array, and the matched records from the right dataset. If there is no match, the result will still include the records from the left dataset, but with null or undefined values from the fields from the right dataset. This is the expected output. So as you see, the expected output contains all records from the employees array. If there is a matching emp ID in the departments array, the records are combined. If there is no match, the record from the employees array is included as it is. It simply combines the records from the employees array, the left one, with the departments, the right array, based on the emp ID, this key. So similarly to the previous exercise, we will start a function that will take three parameters: array1, array2, and the key. We initialize it an empty array to store the results. Now we will write a for loop that iterates over the first array. Now we will define a boolean variable that we will initiate to false in order to track if a matching key is found in array 2. Now we will write an inner loop that iterates over the second array. Now inside the inner loop, we check if the key value in the current object of the array number 1 matches the key value in the current object of the array number 2 department. So if the keys match, we use the spread operator to combine the properties of the current object from both arrays into a single object. This combined object is then added to the result array. And since we found a match, we set the bool variable to true. And then after this inner loop completes, we check if the bool variable is still false. And if it is, it means no matching key was found in array 2 for the current object in array 1. So in this case, we add the current object from array 1 to the result, to this result array. So here with those lines we ensure that every object from the left array, so the array 1, is included in the result. If no corresponding object is found in the right array, so number 2, in the array number 2, if no object is found there, the object from array 1 is added to the result as is. So this behavior is very important for maintaining the integrity of the left join operation, which guarantees inclusion of all records from the left dataset. Remember, the bool variable is used to track whether a matching key is found during the iteration over the second array. So during the nested loop, here the nested loop that iterates over the second array, the code checks if the key values from array 1 and array 2 match. If a match is found, the bool variable is set to true. And if bool variable is still false, it means no match was found for that object. Therefore, the object from array 1 is added to the result as it is. So let's see what we get as a result. So as you see, the final output represents a complete list of employees with departments added where matches were found. So in this exercise, we should write a function that takes an array as a parameter and organize its elements into a single array that contains two separate arrays. One array holds all the numbers found in the input array. The other array stores all the strings or letters, so that we make sure that the output contains numbers and string elements separated but contained within a single array structure. So first, two empty arrays, numbers and string, are initialized to store numbers and strings respectively. And now we will filter the input array to collect elements that are of type number. So first we apply the filter method that is used on arrays to create a new array with elements that pass a certain condition. And in this case, item represents each element of the array as it iterates through, and type of item equal to number guarantees that only elements of the input array that are of type number are included in the filtered array assigned to numbers. So we are kind of checking if the elements that we are iterating through are numbers. And now let's do something similar, but assigning to the strings all the elements that are strings. And for that we will again apply a new type of that checks if the elements that we will be iterating are strings. So let's copy. Okay, so now we filter elements from the input array that are of type string. And now let's combine the arrays, numbers and string into a single array. So this single array will be an array that will contain two sub-arrays, one for numbers and the other for strings. And the function finally returns this result array, which represents the structured output where numbers are grouped first, followed by the strings. And let's check this in the console. So you see, in one hand we have the numbers, the first array, and on the other hand we have the strings. And in case you want to sort the strings alphabetically, let's write just sort method. By adding just the sort method, we have the letters ordered alphabetically. Alright, so here we should write a function that takes an array of numbers and target sum. The function should find all pairs of numbers in the array that add up to the target sum and return them. So for example here, the target is 18, and if we look at the array, which numbers sum up to 18? 12 and 6, 7 and 11. So the function should return these values. So for that we will define a function that will take two parameters, the array or numbers and the target. So these two empty arrays, the first one, result, is to store pairs of numbers that sum up to the target value. So as the function iterates through the numbers, which is the array, and finds pairs that satisfy the condition, these pairs are pushed into the result array. And the helper array is just to keep track of numbers encountered during the iteration through the numbers array. So now we have to iterate through the numbers array, and for that we will use the foreach method. And now we will write a condition that checks if the current number I is less than or equal to the target value. This guarantees that we only consider numbers that could potentially be part of a pair that sums up to the target. And now we will set a nested condition inside this one. This expression here checks if there exists a boolean value stored as the index target minus I within the helper array. This index corresponds to a number encountered earlier in the numbers array. So if this expression evaluates to true, it means that the number target minus I has been seen before, meaning that I and target minus I together form a pair that sums up to target. And if helper array target minus I does not exist or is false, is marked as encountered by helper array equal to true. So this logic identifies pairs of numbers in the numbers array, input array numbers, that adapt to target using a hash map, this helper array, to track encountered numbers. So this part, target minus I minus the iteration variable, computes the complement needed to reach the target sum, and the whole part of this condition checks if this complement has been encountered before in the iteration. Therefore, if this exists, this condition confirms that target minus I minus number has been seen earlier in the array. Therefore, target minus I and I together form a pair that sums up to target. So it is then pushed into the result array. And if this does not exist, is falsy, this means that target minus I has not been seen, has not been encountered yet in the iteration. So to somehow mark number or I, to mark I as encountered, sorry, not number here, I, to mark I as encountered, we set it to true. So let's see what we encounter in the console. So in this case the target is 28, which pairs sum up to 28, so 12 and 18. So this part of the code checks if a specific number, which is necessary to achieve the target sum, has been encountered earlier during the iteration. And if it exists, it means target minus I has been seen before. This means that I and target minus I together form a pair that sums up to target. Good, so here we should rotate a square matrix 90 degrees clockwise. So we should swap rows and columns, then reverse each row of the transposed matrix, and this process results in the matrix being rotated 90 degrees clockwise. The goal is to transform the input matrix into its rotated version, like it's here in this example. So this should be the output. So as you see, the last row becomes the first column, the second to last row becomes the second column, and so on. Each element's position shifts 90 degrees in the clockwise direction related to the original matrix. So let's define a function that will take a matrix as a parameter. Good, so I defined two loops. To nested loop, the outer loop iterates over each row of the matrix. So I represents the current row index. So it ensures that every row of the matrix is processed. And the inner loop iterates over each column up to the current row index. So J represents the current column index, and this condition guarantees that each element below the main diagonal, so from the top left to the bottom right, is processed once. And by doing this, we are swapping elements only once to avoid reversing the transposition. So with this condition, the inner loop focuses only on elements below the diagonal, which means each pair of elements I and J and I is swapped only once. This avoids redundant operation that guarantees that each transposition is performing only once. Now inside the inner loop, let's create a temporary storage for the value located at the position I and J in the matrix. And why a temporary storage is needed? Because when you swap two elements, you need a place to temporarily hold one of the values so you don't lose it during the swap. So here we capture and save the value from the matrix at row I and column J. We are kind of preparing for swapping. This temporary storage holds the original value so that matrix I and J can be assigned to a new value from another position in the matrix without losing the original value. So here we store the original values, and now we will swap value from Ji to ij. For example, to ij. We will do that now, which is part of the matrix transposition process because it assigns the value at this position to this one. And this is done to swap elements above and below the main diagonal, turning rows into columns. And by doing this for all the elements, the matrix is transposed, meaning its rows and columns are interchanged. So, as I said, this line is part of the process of transposing a matrix. It copies the value from position J and I to position I and J. And to fully transpose a matrix, you also need to store the original value of matrix A and J. in a temporary variable that then completes the swap by assigning the stored value to matrix J and I. And now let's complete the swap. And this line completes the swap necessary for transposing the matrix. It assigns the value stored in the temporary variable to the position ji. Next line assigns the value ji to ij. And to complete the swap, the loop assigns the stored original value to ji. And this final line here completes the swap by placing the temporarily stored value into its new position. And now we will write a line that is very important to rotate the matrix in 90 degrees clockwise after transposing it. So, and finally, this completes the rotation of the matrix by reversing each transposed row, resulting in a 90-degree clockwise rotation of the original matrix. The reverse method reverses the order of elements in the current row R because it modifies the array in place and returns the reversed array. And the result of item reverse is stored in final matrix, creating a new matrix where each row is reversed compared to its counterpart. And that is what we are going to check now. And the result indicates that the matrix has been correctly transposed and each row has been reversed. Each element of the matrix M was swapped and with its corresponding element across the diagonal. So let's compare it with the output that we were expecting. So the matrix M is transposed, swapping rows and columns, and each row of the transposed matrix is reversed, because in the transposition step each element at position I and j in the original matrix M is moved to position j and I in the new matrix. And finally, after transposing, each row of the resulting matrix is reversed in order. This completes the 90-degree clockwise rotation of the original matrix. Good, so in this exercise we need to create a function that calculates the total daily earnings for a worker, considering both regular and overtime hours. Regular hours are from 9 to 5 p.m. to 5 p.m. are the regular hours, and any hours worked after 5 p.m. are considered overtime, and they should be paid at a higher rate. So we will start by creating a function that takes an array as a parameter with 4 values: start time, end time, hourly rate, and overtime multiplier. And now we will set up the constant and variables needed for calculating the work hours and the pay. So first we set the starting time for a regular work hour to 9 a.m. Then we set the ending time for 5 p.m. so 17 in 24 hours notation. And with this constant we define the boundaries of what is considered a regular work time. Any hours worked within this range are considered regular hours, and any hours worked beyond this range are considered overtime. And with regular hours we initialize a variable to keep track of the number of regular hours worked. Starting with 0 makes sense because initially we assume no hours have been worked yet. And same with overtime hours. These variables will be used later in the function to store the calculated hours of a regular work and overtime work. And by initializing them to 0, the function ensures that there is a clear starting point for these calculations. Now we will calculate the number of hours worked within the regular working hours from 9 to 5 by determining the overlap between the actual working hours and the regular working hours. So with this condition we check if any part of the work period falls into the regular working hours. This part. Here we check if the start time is before 5 p.m. So if the start time is after 5 p.m. there are no regular hours worked. And here we check if the end time is after 9 a.m. If the end time is before 9, there are no regular hours worked. And if both conditions are true, it means that at least part of the working period falls within the regular working hours. Now let's calculate the regular hours. So to determine the start of a regular work period, in this line, we guarantee that the regular work period starts at the later of the two times, the actual start time or 9 a.m. So here we handle the cases where the workday starts before or after 9 a.m. So start is the actual start time of the workday given as input to the function here. Regular start, this is the start time of the regular work hour, which is 9 a.m. And this native JavaScript function math.max is used to guarantee that the regular work period does not start before 9 a.m. regardless of where the actual work period starts, it takes the larger or later of the two times, start and regular start. So if start is before 9 a.m., for example, say at 8 o'clock, 8, then the regular work period should still start at 9 a.m. And this adjustment is necessary because regular working hours are defined to start at 9 a.m. So any work starting before that time should be counted at starting at 9 a.m. Just for the purpose of calculating regular hours. Alright, so here in this line we determine the end time of the regular work hours within the given work period, because here n is the end time of the regular, and is the actual end time of the working day given as input to the function. Regular end is just the end time of the regular work hours, which is set to 5 p.m., so 17. And the function math.min is used to ensure that the regular work period does not extend beyond 5 p.m. Similarly to this line, but the opposite. If, for example, math, let's make quickly a comment. The output in this case, if, for example, 16 and 17, math.min takes it picks the smaller number. With max, it picks the greatest number, but in this case, we are interested that if n is before 5 p.m., for example at 4 o'clock, then the regular work should end at 4 p.m. We just wanted that if it is the case, the regular period ends at earlier or either the actual work end time. And here we calculate the number of regular hours worked. It guarantees that the number of regular hours is never negative, even if there is no overlap between the work period and the regular hours. So regular work and, sorry, my mistake here, I missed work in the middle here. Regular work starts. So this variable is the calculated end time for the regular work period. Regular work start is the calculated start time for the regular work period. And the difference between end and start times is because we are calculating the duration of the regular work period. If regular work end is after regular work start, this will be a positive number representing the number of regular worked hours. And why this calculation is inside math.max? Because we want to ensure that the result is never negative. This difference, could potentially be a negative number if the start time is after the end time. So using this function with 0 at the beginning, we ensure that the minimum value assigned to regular hours is 0. So good, so now let's calculate the overtime hours. So this conditional block calculates overtime hours only if the end time of the workday, which is represented by end, extends beyond the regular work hours, which is represented by regular end. So in this way we guarantee, let's say, accuracy by starting the overtime calculation from end of regular work hours and subtracting it from the actual end time. So here we check if the actual end time is greater than the regular end time. If it's true, it means that some portion of the workday extends beyond the regular work hours. So if the condition is true, indicating overtime, this part ensures that the overtime calculation starts counting from the later of 2 times, which is the actual time, the actual start time start, or the regular end time, regular end. This is necessary because overtime only starts after the regular work hours have ended. And when we calculate this difference, we are calculating the duration of overtime by subtracting the later time from the actual end time. This gives the total overtime worked. For example, if the workday starts at 9 a.m. and ends at 6 p.m., this would be something like minus math dot max this math.max results in 16 since 9 is less than 17, so it takes the later time, and then the result from this operation results in 1. Therefore, in this case, the overtime hours would be 1, indicating that 1 hour of overtime was worked beyond the regular work hours. And now, finally, let's do the calculation for the total pay for a day of work based on the hours worked and the hourly rate, considering both regular hours and overtime hours. So in regular pay, in this variable, we calculate the total pay for regular hours by multiplying the number of regular hours by the hourly rate, which is right at the beginning. It is an input variable that we should include later in the console log. The next one, overtime pay. In this variable, we calculate the total pay for overtime hours by multiplying the number of overtime hours by the hourly rate, and then multiplying by the overtime multiplier, which is, in this context, multiplier means it refers to the factor by which the hourly rate is multiplied to calculate the overtime pay rate. So it's a value that represents how much more an employee earns per hour when working overtime compared to regular hours. For example, if hourly rate is 30 and the multiplier is, if the multiplier is 1, and the hourly is 30, it means that the overtime rate is 30 multiplied by 1.5, which is 45 per hour. And now finally total pay. We calculate the overall total pay for the day by summing up the regular pay and the overtime pay. And now let's return it. Good, so now let's console log. And here we got an error because instead of const here we should use let, which is good that you see this error so that you understand the difference. If I declare a constant here, this value cannot be changed once it has to be assigned. And by adding here let, you guarantee that the variables can be reassigned as needed, allowing the function to correctly calculate and update the values based on the given input parameters.